Hi everyone, today we're talking about applications of our geometric sequences. Pretty much taking our geometric sequences from the equation and putting it in context into like maybe real life situations that you might run into. So in our first example, in my first job, I earned $42,000 as my yearly salary. And my salary gets increased by 4% each year. I wish. Let's calculate how much I earn in my 10th year of work. So I look at this situation as a geometric series because my salary is growing by a multiple of 4% each year. We have our starting amount, which is $42,000, and then each year it's growing by 4%. So if you want to figure out how much it grows, kind of like in a little chart to organize ourselves to begin with, at year one, my term would be U sub 1, and I made $42,000. Now, the following year, that would be U sub 2, I would take that 42,000, and you need to be careful about what you multiply it. If I multiplied by 0.04, that would be how much of an increase I got. If I wanted to use 42,000 and have my answer right away, I'm going to use 1.04 for that 100% plus the 4% increase. And that would give me a salary in my second year of $43,680. And then to find my third year salary, I'm going to take the previous answer and multiply it again by my 1.04. And I have 45,427.2. And then in my fourth year, I could keep doing this, but nobody really wants to keep doing this. I hear you, even though I don't. All the way up until the 10th term. So let's just write the rules so we can plug in 10 and figure it out right away. So we're going to use our rule for our geometric series or sequence as U sub n is equal to U sub 1 times r to the n minus 1. So we want our 10th term, U sub 10, and that would be equal to our first term, which we have, 42,000, multiplied by our common ratio is that 1.04 raised to the 10th power minus 1. I simplify that down. Make sure you follow order of operations. That's 4200, 1.04 to the 9th, which is, in the end, 59,779 and 10 cents. That would be my salary in the 10th year. Okay, moving on. In this example, we've got a ball is dropped vertically. So we're only calculating the vertical distance here. It reaches a height of 2 meters on the first bounce. So I drop the ball, and now we're calculating after it hits the ground, it's bouncing back up 2 meters. So that is in my first bounce up. I'll call that U sub 1. And then the height of each subsequent bounce, it's not going to bounce up always to 2 meters because we have gravity that will not let it rise as much. So the height of each subsequent bounce is 80% of the previous bounce. So on the second bounce, which would be, whoa, what's that? U sub 2 would be 2 meters multiplied by 0.8 for 80%. And it would only get up to a height of 1.6 meters And then on the third bounce, it's only going to rise up the 1.6 times 0.8 again and get up to 1.28 meters. So on and so forth. On the fourth, we would take that 1.28 multiplied by 0.8, blah, blah, blah. So keep going. Now, no one wants to just keep multiplying like that. So let's write the rule and then we can plug in to find our sixth bounce. In part A, we want to find the height of the ball reaching on the sixth bounce. So that's over here. We want the height right on our u sub 6. Let's write the rule. So our u sub n is equal to u sub 1 multiplied by r to the n minus 1. So u sub n, u sub 6 is equal to our first term, which is our 2 meters, multiplied by our common ratio of 0.8 to the 6 minus 1, which when you drop that into your calculator to the 5th power, you get only a little height of 0.65. Well, let's round to 6. So over here, you've got a height 0.66. But it also asks to find the sum of the first 7 terms of this sequence. We're going to use our sum formula to calculate the sum up until u sub 7. So ignore that calculator for now. We'll get to them. The sum up until a 7th term would just be our equation of u sub 1 times 1 minus r to the n over 1 minus r. And plug in everything you know. The sum up until a 7th is u sub 1 is 2. Oh, parenthesis. 1 minus your 0.8 to the 7th power divided by 1 minus 0.8. All right, so over in the calculator, depending on what calculator you have, you're going to see how many sets of parentheses I needed to add in order to get my solution of 7.90 meters. So that is the total bouncing up distance of that ball up until the 7th bounce. Now you're able to complete section 7F. Have a good day. Miss you guys.